All right. So the recording has started, so go ahead and take it away.
All right. Well, I'm really excited to be able to tell you guys a little bit more about this super exciting feature coming soon for DAX called user-defined functions. So yeah, let's just get straight into it. So just a quick little agenda for today. So I'm just going to give a quick little intro, and then I'll kind of explain the problem and current workarounds that we have for all of this. And then I'll jump into an overview of user-defined functions, and that kind of includes how to work with parameters within them. And then I'll give a really exciting demo, and we'll kind of wrap up for the day. So that's what you guys are all in for. Just a little bit about me. So my name is Haley Steffens. I am a technical program management intern at Power BI. It's actually my second to last day, so very sad. But my manager is Jay, who you guys probably know. I am currently getting my degree in computer science, so I'll be wrapping that up in the spring. And I am new to the Power BI space, but it's been so exciting this summer to be a part of it, and I hope to stay a part of the community. So I'm sure you guys all pretty much know about DAX, but just as a quick intro, DAX is the calculation and query language for Power BI. So it stands for Data Analyst Expressions and can kind of be thought of the brain behind Power BI. So it's a super powerful language that gives users the ability to create and perform sophisticated calculations and queries on the data within the semantic model. So it really does play a crucial role in deriving insights and making decisions in today's data-driven world. And I have a quick history of DAX right here that I thought we could like really quickly run through. So DAX was actually introduced in 2009 within Power Pivot and Excel. And then in 2012, we saw SQL Server Analysis Service introduce the tabular model, which used DAX as the language. And obviously, since we just celebrated the 10th anniversary this summer, back in 2015 is when Power BI released. So very exciting. And then in 2020, we saw the addition of 49 financial functions, similar to functions in Excel. And this kind of shows how DAX is expanding. We also saw the composite models on semantic models, so being able to add additional data sources on top of your semantic models. And then in 2022, we saw the introduction of window functions. So this kind of lets you get ordered items from the database, and it was pretty big for DAX. As well as in 2023, we got to see the info functions get introduced, which models lets you get model metadata super easily and is really great for self-documenting models. And then just last year, we saw the addition of visual calculations, which has been a very big step for DAX, as well as the addition of DAX Query View, which I personally used a lot when I was kind of putting all this together, and I love working with it. And then this year, we've already seen a lot of exciting stuff. So we've seen Copilot generated DAX. You can ask Copilot to generate some of that for you, as well as the introduction of Timdal. So with the new Power BI file format, the Power BI project, you can now work with Timdal within DAX. And there's also that Timdal view that's been introduced. So let's kind of jump into what users are currently struggling with in DAX. So, as many of you guys know, DAX does not have a good reuse story. There's no built-in way to package or call reusable logic, which is pretty odd since most programming languages have some way of reusing logic either through a function or a macro. And we can kind of see this like SQL, Excel, M, all of these have kind of had this function for years. So this gap in DAX can make it feel kind of awkward and hard to maintain as your model evolves. So I'm sure pretty much everybody here who's worked with DAX has had this exact scenario happen where you've copied pretty much the same filter logic into all of your different measures, and then all of a sudden the requirement changes and you have to update every single measure. And this is a very common issue. So let's kind of talk about it. You often need to reuse the same logic in multiple different calculations. And today, like I said, we kind of have to repeatedly implement this calculation across our model. So this leads to brittle DAX code and higher risk of errors. So like for an example, again, that requirement changes, you have to manually hunt down every calculation that uses it and then update each one. So first of all, this is extremely time consuming. And second of all, it's super error prone. It's super easy just to miss a location or mistype in one of the spots when you're trying to update that logic that can lead to breaking your model or subtly changing your results without you even noticing. So all of this just kind of makes models harder and more time consuming to maintain. And we do have a couple partial workarounds for trying to reuse DAX logic. So one of them right now is calculation groups. So we can see that these are model objects that contain different calculation items inside of them. And each calculation item typically uses a selected measure function that lets you kind of operate generically over any measure and just kind of essentially allows you to inject logic on top of measures. It's a little bit more of an obscure one, but you can also use detailed rows encapsulation. So this lets you encapsulate complicated table logic into a measure, as you can kind of see at the top of my example there. And then you can call the detailed rows DAX function on that measure whenever you want to reuse that table logic. So it is a little bit confusing to work with, but it is possible. But both of these kind of have some pretty big drawbacks to them. The biggest one here is that neither of them can take any parameters into them. So this lack of explicit arguments kind of forces inputs to go through an odd filter context, which is pretty unnatural and can make your DAX kind of indirect and error prone. So this leads to like hidden coupling and just generally more confusing DAX. I know when I was kind of looking into these areas for this presentation, I was getting really confused trying to figure out how to work with them. So it's just not as intuitive. Also, performance isn't optimized here. So changing and examining filter context, which is what you have to do when you can't explicitly pass a parameter, just does not get optimized well within Power BI. There's also limited flexibility here. So you can't control when an expression's evaluated or that context there, the way that true functions let you. As well as for the detailed rows workaround, you actually can't do this within Power BI. You have to use a third-party tool to add this in. So all of this is just pretty tedious and frustrating, and I'm sure many of you guys have felt this way trying to work with this. So I'm really excited to get to introduce user-defined functions to you all today. So this is a feature coming soon to DAX, and it's really going to be a huge step for the DAX language. So with DAX user-defined functions, you can define multiple functions, or you can define reusable functions with parameters, just like you can in regular programming. So instead of having to copy and paste that logic across multiple calculations and measures, you can just write your logic once and reuse it throughout your whole model. So this makes your DAX code easier to write, understand, maintain, and debug, which is really game-changing when you're working with complex models or just wanting to write more clean and maintainable DAX. So you can use user-defined functions just like you would any built-in DAX function. There's a new function keyword that's being introduced that lets you easily declare user-defined functions within one of its multiple access points in Power BI. And for each function, you can include optional parameters to add greater capability, and within that, even declare what type the parameter has to be for more controlled functions. You can also use one of the several new type checking functions to help build stronger and more resilient functions when you're writing them. And there's many more exciting capabilities that come with user-defined functions. So you can create a user-defined function in multiple spots. You can use DAX Query View, which is what I primarily use. I think it's really good if you want to also test your function while you're writing it. So this lets you easily define and evaluate queries. You can also use Timdal View. So if you save your project as a PBIP, a Power BI project, instead of a PBIX file format, you can use Timdal View here to inspect, script, modify, and apply changes to your model objects, including user-defined functions. You can also use Model Explorer, which is an easy tree view of model objects to work with your user-defined functions, as well as if you have saved that as a Power BI project, you can view your functions within the Timdal script of your project. So this is just a snip taken from VS Code. You can use any code editor and also work with that there. You can also use user-defined functions anywhere you can currently use built-in DAX functions. So this includes measures, calculated columns, visual calculations, and even other user-defined functions, which is what I think is the most exciting. And the syntax here is very intuitive. It's very simple, similar to other programming languages. So you can declare an optional description above your function with that 3/, and you declare your actual function with the function keyword and then the name you'd like to name it. And then after that equal sign is where you define your parameters, and you can assign any parameter types to them. And then after that equal greater than is where you actually put your function body, and this is all your logic for your function. So I have a simple example. This is in DAX query view. So here you can see that this function, based off of the function ID here, takes the customer ID as input and then returns the total sales for that customer. So this is just a very simple function, kind of show you guys around. And you define a function in DAX query view within a define block. So you can see that here. And you can see obviously the name for this function is customer lifetime value. We have one parameter too. This is customer ID. And then the actual logic here is pretty simple, but it's a calculate function that basically just finds the total sales for customers with that corresponding ID. Once this is saved to your model too, it's really easy just to see quick information on it. So if you hover on top of your user-defined function, it'll be similar to any built-in DAX function where it'll give you that name and the parameters, as well as that description if you've inputted it, and just given you a little sight into your code there so you can see what's going on easily. And you can also evaluate user-defined functions in DAX query view. So you can see here I have an evaluation statement, and if we run that, you get a value very easily. I personally like to use this a lot when I'm just testing my user-defined functions before I actually add them to my model to see that they're kind of working as I expect. So once you do feel confident about your function, it's super easy to save it to the model. You can either do that at the top or right above the function. There's a little thing you can click on, and this will save it to your model. And once it's saved to your model, it'll pop up in Model Explorer. So there's a new functions tab here that lets you view all of your functions inside the model and quickly work with them. So for example, if you're in DAX query view, you can right click on any function and do quick queries on them, just like you can with measures. So this lets you evaluate, define new functions, and define all functions in the model. So again, this is really similar to measures in DAX query view currently. And like I said, you can also use this in Timdal view. So as you can see, the syntax is pretty much exactly the same. There's really no big difference here. The only thing to note, since this is Timdal and not DAX, is you just use a create or replace in front of it instead of a define block. But that's really the only difference here. You can use them just as easily in Timdal view. And again, you can just apply here to save that to your model. Also, Model Explorer within Timdal view, you can do a very similar thing where you can right-click on it and you can script your actual function to the Timdal script. So that'll just quickly pull up your function. And you can also just drag and drop that straight onto your Timdal view to go ahead and see that function and work with it quickly. And like I said, you can use Power BI projects as well. So you can see I have VS Code pulled up here, and you can see all of your functions are stored in the functions.timdal extension. So this is in your semantic model file. And this again is just another way for you to quickly work and view your functions. You can also use the info functions just like you can with normal functions. So here you can see I have all my user-defined functions that pop up when I run this. And you can see also that if you use origin and to parameters, that this will get you only your user-defined functions instead of all of the functions. So again, this is great for just getting that quick metadata on any user-defined functions within your model. And here with user-defined functions, the sky's really the limit. So you can create pretty much any function you can imagine and use it seamlessly within your model and reports. So I have a couple examples here. You can use, with the customer lifetime example we kind of walked through, I show that you can use it in measures, so you can see just how simple your measures can be here. So again, this is just a very simple measure using that. And you can also use the same thing in calculated columns. So this is pretty much the exact same example, but on a calculated column. As well as you can use user-defined functions in visual calculations. So I do want to note here, though, that since visual calculations only operate on the fields present within the visual, your user-defined function can't reference fields that aren't present in that visual, or else there will be an error. So our customer lifetime value example here wouldn't work since it uses the customer table and the total sales measure within its actual function. And so if you call it within this visual calc that doesn't contain that information, it won't be able to reference that. So that's what's going on here, but you can still use functions that don't reference things outside of your visual. So you can see I have a simple add tax function here, and that works great in visual calcs. And you can also use user-defined functions in other user-defined functions. So this is really great if you want to use helpers for functions or just try to block off your code into different like logical sections. So here we use that customer lifetime value example again in another function called average order value, which basically just takes the customer lifetime value, so the total sales for that customer, and divides it by the number of sales that they have had to get their average order value. So again, you can see it's really easy to kind of break off your logic into different functions and then reuse them everywhere in your model. Also, parameters are part of the reason of what makes user-defined functions so powerful, so I kind of wanted to touch on how those work. So with a user-defined function, you can have 0 or more parameters within them, and each parameter can be assigned different types of type hints, so you can basically assign what type of data has to be passed in for that parameter. And then you can use type checking helpers to build more resilient functions with this. So let's kind of look at what this all means. Here you can see I have another few simple examples. So you can see the first two functions, multiply and add 1, use 2 parameters here, and you can use however many you want in your functions. And then the bottom example, random int, just shows that you don't have to use parameters if you don't want to. They're just as simple to work with. And parameters, you can also assign, like I said, type hints to build more predictable functions. So this is similar to other programming languages, how you can say that something has to be a whole number, how it has to be a Boolean, that type of thing. And within this, we have 3 different levels of parameter type hints that you can put in. So we have type, subtype, and parameter mode. And I'll kind of jump into what those mean. So type references the type of value a parameter accepts. This is high level, so this is, does it accept a single value? Does it accept a table? That type of thing. Subtype is for a single value, you can specify what specific data type it is. So is it a decimal? Is it a string? Is it a Boolean? That type of thing you can specify here. And then what I think is the most exciting here is you can specify parameter mode. So this is when your argument's evaluated. So it's eager versus lazy evaluation, which is basically, is it evaluated before it's passed into the function? So let's say I have 1 plus 2, that would be evaluated to 3, and then the 3 would be passed into the function, versus if it's lazily evaluated. So that 1 plus 2 expression would actually be passed inside of your function and then evaluated in the context within the function. So again, this just gives great control over how you want to use your parameters. And I have a really simple example here. So this is just a simple function that casts whatever the parameter is to an int. So you can see we have all 3 levels of type hints here. So we have a scalar, which is saying it has to be a single value. And then we say that the subtype is an int 64. So it has to be a whole number here. And then we set the parameter mode to value, which just means that it is eagerly evaluated. So it would be evaluated before being passed into the function. And here you can kind of see a runtime example. So we can see that things are actually cast to that type. So in this case, 3.4 is rounded down to 3, 3.5 is rounded up to 4, and then 5, which is put in as a string, is changed to the whole number type as a 5. And since we aren't really using the other parts of the parameter type hints, we're really just trying to cast to that whole number here, we can actually just use the subtype. So you don't have to use all types of type hints. You can kind of mix and match them within your parameters. You can also use different type checking helpers to help you build more resilient functions here. So you can see that some examples here is int64, is string, is Boolean. Basically, you pass a single value into this and it'll just return a true false if it is that data type or not. So you can use this to help mitigate errors within your functions. I have a quick example here. This is a string length function. So all it does is it checks, is the parameter that's passed in a string? And if it is, it'll find the length of that string. And if not, it'll return a blank. So instead of erroring out, if you put something like I have in the evaluate area, like a 1, 2, 3, instead of erroring out, you can actually account for those different type of inputs this way. So again, this just lets you build stronger functions and lets you build more modular functions. So I do have a demo, so let me stop sharing this presentation and pull that up for you guys. One moment. Sorry, 1 second.
Oh, you're fine. And just so everybody knows, I've been capturing the questions in the chat and we'll go over them towards the end when she's done
Oh,
with her
great.
demo, because a lot of them might get answered by then. And I know Jay's been answering a couple things in the chat. So
Yeah, great.
everything's
So
great.
perfect. All right, so I have a pretty simple demo file set up here. You can see this is actually using the AdventureWorks 2020 kind of learn sample here. So if you guys want to follow along with this later, you're welcome to. But if we go into DAX query view, we can see we have our model explorer right here, and you can see we already have a couple of functions shown here. So again, we have that customer lifetime value function that we looked at, as well as a couple others. And let's just check that we can actually view this. So if we right click on this, we can go quick queries and define and evaluate. So this will pull up our function and we can see, yep, this is as we expect. And then if we want, we can also evaluate it. So I have a couple customer IDs pulled off to the side that I can pull up and we can just see how easy it is to work with this. So here I have one customer ID, let's input that. And then we'll also evaluate another one. So I'll start typing that in and you can see it pops up right there and you can just autocomplete that like you can with any built-in DAX function. And let me grab another customer ID. All right, so we have a couple here. Let's go ahead and run this. And we can see, yes, it does give us the total sales for those customers. You can see the top one has a lot more sales than the other. But again, this just shows how easy it is to work with these calculations. And now I want to kind of show how easy it is to actually make one. So I have a pretty simple example first, and then I'll kind of talk you through a more detailed example that I've made already. But let's just make a simple add tax function right now. So we're gonna start with defining, because we define our function in a define block. So we're gonna say define, and then we'll use the function keyword to say that we want to write a function. And we'll just call this function add tax. So what I usually like to do at this point, which is optional, is put in the function description. So I'll go in here and I'll do the 3/, which is what you do for putting in the description. And we'll just say that add tax returns the amount, including tax. So it's a very simple function, but this just kind of shows how easy it is to make one. So now we have that established, we can put in the parameters we want here. So we'll put that equal sign. And then in the parentheses, we'll say we really just need the amount here that we can add the tax onto. So we'll just say we need one parameter called amount. But since we are going to be doing some multiplication on it, we're going to say that it needs to be a numeric type, which is just that it has to be any type of number. It can be a whole number, decimal, whatever. It just has to be something you can perform a calculation on like that. Then we're going to do equal and greater than, and then our function body is right in here. So since this is a really simple function, we're just going to say tax is 10%. We'll just do amount times 1.1. And that's all that this function has to it, but you can see how easy it is to create. And if we want to test, see that it's working as expected, we can use an evaluate block here. So we'll say evaluate, and then we'll go ahead and put in add tax. So we'll start typing that in, and you can see it's already right here. It pops up, and you have those little type hints about it, so you can easily kind of figure out what you're working with. So let's just do something that we know that what the expected result is here. So if we put in 10, we know we should expect 11. And if we run that, yes, we get 11. So our function's working as we expect. We can go ahead and add this to our model since we feel confident about that. So if we update model here, you can see it pops up in Model Explorer, which means it's been saved to the model and can be used anywhere. So if we want to go ahead and use this, let's go to the model view. And you can see we already do have a total sales measure here. So let's just make another measure that's going off of this using our function. So if we go into the sales table, we can create a new measure, and we'll just say that this is total sales with tax. So all we're going to do here is call our add tax function. And since we want total sales, we'll just do it on total sales here. Then we'll save that measure. You can see it pops in there seamlessly. And if we want to just see that this is how we expect, we can go and create a really simple table and just view those two measures side by side. So again, you see this works as expected. This is 10% tax on it. But let's say all of a sudden tax increases to something crazy. Let's say tax is all of a sudden like 50%. Yikes. We can just go straight into our DAX query view and we can change this. Let's say if it is 50%, we'll just change that. Let's run it, see we get the value as expected. Okay, we feel good about this change. Let's go ahead and update our model. Then we can just go into report view again, and we see that that measure automatically updates. So I didn't have to touch that measure at all. I just had to change the function in one spot, and you can see how seamless that is. So imagine you had 50 measures that use this. It's just one change, and all the measures are updated. So this was a pretty simple example. So I wanted to walk you through a little bit more of a complex one that I already created. So this is a convert to currency function. This is just a really simple currency conversion scenario. And you can see I do have a helper above, but I'll kind of get into that in a little bit later as I'm explaining the actual function. But if we go to the main function, convert to currency, this just converts the given amount into a target currency using either the average or end of day exchange rate for a given date. So you can see here that this takes 4 parameters. The first parameter is your currency parameter, and this takes in a single value. And in this function, it can either be a currency key or a currency code. We handle both the same. So if we kind of see what that looks like, if we go into the table view, we can see currency. You can either input a currency code or a currency key, and our function handles both. This is similar also to the date parameter. So the date parameter, you can either pass in a date key or a standard date value. So again, if we want to see what that looks like, we can go to the table explorer and you can see the difference. So this isn't just a standard date value, and the date key is just a whole number based off of that. And then the third parameter here is use average rate. So you can see this is a Boolean. So this is a true or false value. And this is just what we're going to use to see if the user wants us to calculate the exchange rate based on the average or end of day rate. And then lastly, you need to pass in the amount that we're actually converting. So that's what that fourth one is. So I've kind of used variables here to chunk off logic, but you can see that in the first area, we're calculating the currency key based off of if our currency parameter is a currency key or a currency code. So like I said, you can input either and our function works fine with both of those. So we have this variable called currency key. And inside of that, we're checking, is that currency parameter an int64? So is it a whole number? And if it is a whole number, then that means we already have a currency key that the user passed in for that parameter. So we can just save that straight to the variable. If it is not a whole number, we know that that must be a currency code then. So we can go ahead and calculate that currency key based off of the currency code the user provided. And either way, that gets saved to our currency key variable to use later. Very similar for date key. We do the same thing where we basically check, is it a whole number? If it is, that means the user's already passed in a date key for the parameter, and we can just save that straight to our variable. And if not, that means we need to convert the standard date value to a date key, which we use the convert date to date key helper I had above. So if we kind of scroll to that helper, you can see it's super simple. We just take in a standard date value. So we have our date parameter here. And then we just do a simple calculation to get us that date key based off of that date value. And then either way, that saves to our date key variable. Then we calculate the exchange rate here. So you can see we check that Boolean. So we call our parameter that's either that true or false for if we want to use the average rate or end of day rate. So if this is true, that means that the user wants us to calculate the exchange rate based on the average rate. So we do that right in this block. And if that is set to false, that means we want to use the end of day rate. So it's very similar calculation, but we'll just use the end of day rate here. Either way, that'll get saved to our exchange rate variable for us to use when we calculate a result below. So we have a result here. So you can see we calculate that. We do a couple of checks here. So we just check if our parameters are blank. So if the user inputted something odd, not like what we expect, then we'll just return a blank instead of causing an error. And also we check if our exchange rate is blank. So that would mean that for some reason our data does not have that exchange rate available. And if that's the case, we'll just return no exchange rate available. But assuming that everything worked as expected, exchange rate will just be calculated with our amount and that currency will then be converted there. So that'll be our result and we'll go ahead and return that. So this kind of shows how you can use flexible inputs to make your functions work in different ways and just allow greater flexibility for using them. And if we go ahead into model view, we can make a measure with this. So you can see, let's do another total sales example, but you can see that we have both of those functions in our model right here. So that means we can call them. So if we go to the sales table, we'll make another function off of total sales. So new measure or another measure. And let's just call this total sales in local currency. So here we're going to call our convert to currency function we just created. And you can see again, pops right up here. And you can use this IntelliSense pop-up to kind of quickly understand how to actually call it. So here, if we go ahead and put in the first parameter here, we know our convert to currency, that's going to be our currency parameter. So here I'm going to do a selected value from the currency table. And we'll do the currency code here. We'll pass that in. Then we have to put in our date value. So again, we'll do a selected value. And we'll do this for our date table. And we'll do a date key in this sense. Next, our third parameter, as you can see here, is use average rate. So we got to decide if we want to use the average rate or end of day exchange rate. But let's say we want to use the average rate. So we'll set this to true. And then for the amount, since this is total sales in local currency, our amount is just going to be total sales here. And that's it. That's our whole measure. All of that logic that was in that function, you can see translates to creating very clean and easy to understand measures here. So instead of having to put all of that logic inside of a measure and have it be complicated and confusing to understand, it's super easy just to call one function with very simple parameters, and that's it for your measure. So let's see this working. If I open another page and just make another table here, let's say we want to see what date we're working with, as well as the currency we're converting it to. And then we can put in the regular total sales and the total sales in the local currency. So if I go ahead and expand that right here, you can see that we have that currency conversion, and you can see just how easy it is to work with. So again, this just shows a little bit of what you can do with user-defined functions and how easy it is to reuse them. You can use them in however many calculations you want. And again, if you want to update that business logic because requirements change or something else, it's just one single spot that you have to do that. And then all of your different measures and calculations are automatically updated. So let me pull back up my presentation. Alrighty, can you guys see that all good?
Yes.
Great. So kind of like you could see, really here you have unlimited options. It's as much as you can imagine you can really create. And I'm really excited to be able to see once this releases what all you guys create with this. I mean, really, it just brings DAX to a whole nother level, and I think is really going to be a game changer when working with DAX. So I'm really excited to have gotten to present to you guys about this today. And I just want to say thank you. Thank you to my manager, Jay. Thank you to Kevin for helping me put together kind of this last minute presentation. I reached out to him about 2 weeks ago, and he was great about letting me set this up and present to you all. So it's been really great. And I've had a great summer at Power BI. I've learned a lot. I hope to continue here. And yeah, it's been great. So just
Well,
wanted to say thank you. Thank you all for attending. And I'm happy to answer some questions.
yeah, well, let's go through some of the questions. I have a whole kind of document with the questions in there. So let's see what we could go through, and we'll pull Jay in if we have to.
Okay.
If I missed your question or you feel like you need to get a little bit more clarification, please raise your hand and then I'll call on you. But I'm going to kind of group some of these. There's some themes that went on, and I think part of what you covered also answered some of these questions. But let's kind of go with this theme. I'm going to kind of make up a question from about 4 of them here. Um, where will these functions live, and will we be able to use them across models or across reports, and a way to kind of share them somehow?
Yeah, so these live in the model. So this will live in your semantic model. You can see them in Model Explorer and like that Power BI project semantic folder as kind of shown. So if you're using the same semantic model across different reports, you can use this across different reports, but they will live inside the model. And I believe that that you can't share them across models, but Jay can confirm too.
Yeah, and it kind of
So
goes, go ahead,
so
Jay.
it so if you have Haley is right, right? So if you have multiple reports pointing to the same model, you can of course call the functions from all those reports.
Mhm.
Um, you can also call a function from a composite model. So if you have, let's say, a composite model that uses a semantic model as a source, if your, let's say, the semantic model A is your source, you define a function in A and you have a model B depending on that source, you can absolutely call the function from model A in B. But you have to think really hard about the context because of course the context of the original model still applies while you're calculating something in model B. So you have to tread carefully, but yes, you can absolutely reuse them in composite models. The only thing that is, I would say, broken, quote unquote, right now, there's no IntelliSense in this scenario. So
Mhm.
you can type the function name, it will work, but we won't recognize the function name if it's not in your immediate model. So you have, add text defined in model A. In model B, you type add text 10, it will work, but it will just give you red squigglies when you type the measure.
Right. Okay.
So
Let's kind of move on to kind of performance and debugging. There was a couple questions around that. So, can we just nest functions to our heart's content, or with the recommendation to be a little bit careful around there? And then, in doing something like that, what would debugging or even performance testing look like?
Yeah, so as far as I'm aware, you can nest functions as much as you like. I will kind of shift the floor again to Jay to kind of talk about performance here, as I'm not quite sure about that.
who asked this question? It must be Bernard, right?
I think it was, yes.
I mean, no, I mean, there is no technical limitation we put in place. There's no like hard stop, right? We didn't say like, oh, you can only nest 5 functions or whatever deep. We didn't put anything like that in place. So there's no hard-coded limit. I do think there's a very practical limit. And that's because it's about code complexity. Like at some point, if you nest to infinity, at some point, the machine, especially if you start jumping across models, in a composite model scenario, will just grind to a halt. So I would say there is no technical limit, and I think the limit is going to be in your practical situation. How much like performance are you willing to give up for clean, composable code? Now, do functions have overhead? No, not really. Are they potentially in the future even better optimized than writing the same logic in a separate measure? Yes, but that work hasn't been done yet because we need to figure out what people do with this before we are able to optimize for certain scenarios. So right now there's no optimization. So I would say, regardless if you use a function or a measure, all things will be equal. But you could imagine that we would at some point be able to say, hey, here's a function. That function gets a measure, we know that the measure is not going to change value in this context, so we can kind of pre-calculate the result of the function and cache it for you. If we did something like that, then functions could potentially be faster than executing the same code in a separate measure, if you understand what I mean.
Mhm.
But none of that has
That
happened yet.
that
So
make
now
that
they
makes
should be
sense.
on the same line as measures. It's just about like componentizing or modularizing your code, making it easier that way. Yeah,
Yeah.
that's I think all I have to say on this.
Okay. And
Try it.
so, yeah, and right, when it comes out, people could try it and we'll find out. But
Yeah.
for kind of checking for performance, right? And a lot of people use a tool like um not tabular editor. Tabular editor could help, but DAX Studio. right? Really kind of helps you kind of see the plan and things like that. You know, all of these will I would imagine still work with that. Somebody also brought up evaluate and log. You know, all of those techniques are still available to you to help figure out your performance and then try to figure out what's going on with that. Is that a true statement?
Absolutely, yes. It's just in the model, so yes.
Okay. That covered a lot of the questions. One person did ask about can the UDFs be stored in a Fabric Lakehouse? And I don't know what the use case is being thought of there, but since they're stored in the model, right, I'm imagining that that's no. And you know, you'll use something like Tyndall. You could capture the Tyndall and cut and paste it between models to move it from places. So I
That is
kind of asked
correct.
and answered at the same time.
I mean, a lake house is not an AS model, therefore functions don't exist, right?
Exactly. Exactly.
We're
Now,
talking about DAX here, and DAX doesn't live in a lake house.
if you wanted to use that to kind of store text files in the files area that are all your functions or your Tyndall for
You
the
could.
functions, sure,
Absolutely. Yeah.
right? You could do it in a Git repository, like Jay mentioned in the chat, just for the recording. You'll probably see the community, you know, fill in different ways of maybe there'll be multiple shared GitHubs or something. I fully expect to see that coming. So let's see. So what else? I think that covers kind of the gist of all the questions. Again, raise your hand if I missed anything. I know somebody did ask, is there a place that they could go get training on this? But since it's not released yet, that answer has to be no. Um,
That answer
I,
is no, but of course there will be extensive Learn documentation written by
mhm.
Haley, on which she did an amazing job. Um, and that will tell you everything you need to know. And then, of course, you know, if you've been around in this community for a while, you know that we kind of like work very closely with select MVPs as well, or all of our
Mhm.
MVPs, and some of our MVPs have already like lined up blogs and white papers and stuff like that about this functionality.
Yep.
The people on Tableau Editor, for example, have also like have pre-cooked the release. So as soon as this goes out, then that will also be supported. So there will be a whole slew of information coming out, not just from Microsoft, but right now, yes, of course, you won't find anything because it's not public yet.
Yep.
And I guess there will
Uh,
be books about this as well at some point. Who knows?
you never know. Never
Yeah,
know.
exactly.
Okay, last chance. Anybody have a question that you want to raise your hand? Um, Still unanswered. What does a DAX query look like from visuals? Just so what do these look like in Performance Analyzer? Okay, so in Performance Analyzer inside Power BI, I'm thinking was Jake's question. You would still end up seeing, you know, the performance. You'd see the timing, just like you do on any of your DAX measures. I don't think there's going to be anything specifically broken down to say the function took this much time of the measure. Would that be correct, Jay?
Yep, that is correct. I mean, it's very simple.
Mm-hmm.
You just wrote a piece of DAX and you just sent it off to the database. It is up to the database to handle that somehow. And the database goes and read whatever DAX you wrote, which is, let's say, add text 10, and goes like, oh, do I understand what add text is? And it goes like, oh, yeah, there's a function over here. Okay, let me just execute that. So all of that is opaque to the performance analyzer. You just sent off the
Mm-hmm.
query. You don't see what is happening. Oh, going like, oh, this is a user-defined query, so function. So I'm going to spend like n milliseconds on that, and then n milliseconds on the rest. None of that is shown. It's just basically you're sending the query off to the database, and that's it. So if you have, let's say, a simple, to riff off the example that Haley has been given, right? Like the amount including tax um,
Mm-hmm.
thing, right? So you have like a measure that is amount including tax is add tax of sales, right? You put that on a visual, then your query will just be evaluating that measure. You won't see that that measure is actually calling a function. It's just a measure,
Right.
right? So you will not see the function in the query because it's just a measure. And we don't show you the DAX inside of a measure that doesn't use a function either in the query, right? We just show you that that measure got evaluated, and that's essentially how we treat measures that call functions. You just see the measure. That's it.
Right. Yeah, it'll be a very similar thing. So still back to using DAX Studio, right, which I think answers the question some more, right? You'll do whatever you're doing in your query inside DAX Studio, and then when you turn on the have everything evaluated, right? You see how that gets turned over into storage engine calls or what happens in the formula engine. It's still going to be your best place to go to. So I think that is the way to is the answer to the question. So hopefully, Jake, if that doesn't,
No,
go ahead
that's
and
the same thing as how you
mm-hmm.
work with optimizing DAX in general still
Yeah,
applies.
right,
Nothing has changed there because of functions because they are just opaque to your front end. You just call the function, whatever
right.
happens to be inside of the function, you don't care,
Mm-hmm.
right? So it's just an artifact in the database. So maybe another way of thinking about it, just as much as you don't see how sum x under the covers is actually a shortcut to something else, or running sum is a shortcut to window, you
Mm-hmm.
don't see that. Same with this. Your function is just a function. You don't see what's inside.
Yep, makes sense. There's been a couple questions. I was holding this out to the end, but obviously, people want to know when this is coming out. I don't know that you have that you want to produce a release date because things may change, and typically that's the way. But as always, kind of watch around big conferences coming up, and you usually hear things going on during that time. So we have one in Vienna next week, and there's Ignite later in the year. Who knows? Could be either or. Unless Jay, you want to add on to that.
Yeah. No, I mean, I think you handled it beautifully. Um, we're not giving release dates
Hmm.
publicly, but of course, big conferences are coming up, so I would absolutely stay tuned for announcements in this area. We have been talking about this for a while. I think the first time that we talked about it is in FabCon half a year ago, if I'm not mistaken,
Hmm.
in Vegas in
Hmm.
March.
Yep.
Um, I did a user group session about this a little while ago. Now we have this. Marco Russo, the SQL BI folks have been having done some information about it. But I cannot give you release dates.
Yep. Makes sense. All right. Well, with that, I am going to stop the recording and say thank you to everybody that showed up. And thank you, Haley, for presenting. This was